Let's get started with part 4 of Lab 4, where we're going to look at some flat-lying sedimentary rocks in a block diagram, and then just do a little bit of crustal deformation, brittle crustal deformation by putting a fault through it. So let's start with just the block diagram A that we're provided, and you're asked to do a few things to complete the block diagram. We can see that we're shown a cross section here, like a cut through the birthday cake, and we can see layers. This will be like a sandstone here, and this will be a shale that we're usually representing as dashed lines here. And one of the things you're asked to do is to draw those layers on the other two sides, on the map and on the side over here. Let's start with the map. So the map has the sandstone exposed at the surface, so it's just going to have sandstone rocks everywhere you look on the surface here. On the side here, we're going to have a layer of sandstone rocks, but of course these other layers are going to be beneath it because this is just horizontal layers. So I'm just going to draw another layer on the side. It doesn't go straight back because we're trying to draw it in 3 dimensions here, which is never easy, but I think the easiest way is just draw a line parallel to this line here. So, you know, once again, you can freehand it in, but draw parallel, and that's going to be where the sandstone layer is. So we can see we have sandstone on the top, sandstone on this side, sandstone on that side, just like the top layer of a birthday cake. And then also, because this is flat line, we're asked to put a symbol on, which we often put, and that's a plus sign on the top of the map to show that everything's flat. So I'm just going to draw in a plus sign here, and often this is inside of a circle, just to show those layers on the top are flat. So the first part of this block diagram is you'll complete a block diagram over here. The other part of the block diagram is that you'll see what would happen if this fault and if a fault develops along the line between X and Y due to extensional forces. So let's talk about how we're going to do this. So I'm just going to clear what I've drawn here. Sorry. And I'm going to just sketch in one side. So essentially we have a fault running through here, like this. And then I'm going to just sketch in one side over here, like that. Put in where the layers are. I can put the symbols on later. I'm just going to put on the layers here. And then I'm going to select all of that. And I'm going to move it over here. So once again, lines up with X and Y. So there's half of our block diagram, and now we're going to show it being offset by a fault. So once again, I'm going to go back to my drawing tool so I can draw the other side now. And it's also going to share this fault boundary through here. But now I'm going to draw the other side in here. Okay, and go back here, get my pointer tool, and I'm going to move this over here. Now, if there was no offset in the fault, it would just all fit together nicely just like it was, but we're saying that there is offset in the fault. That offset is going to be either up in this direction here, or it's going to be down in this direction here. So that'll be for you to determine. And we know it's extensional, so you have to think about what happens when things get extended. Okay, but you're going to go ahead and draw that in, and of course if you want to, you can it should be, these two fault lines should be touching here right in your drawing, but I'm just going to put on the different symbols here. Top one, sandstone, then shale, then sandstone, then shale, same over here. Right? And then you're going to show that offset. So once you show the offset, one of these sides here, you're going to label as the hanging wall, and the other is going to be the foot wall. So, you know, you'll put that on one side or the other, but you'll have to indicate which of these is going to be the hanging wall and the foot wall, right? And you'll tell what type of fault that's called, and of course that's all going to be related to how you describe the fault, right? So if the hanging wall moves up with respect to the foot wall, let's take a look at this. I'm going to go ahead and just grab all this stuff. So if the hanging wall moves up with respect to the footwall like that, we would call that a reverse fault, right? And if the hanging wall moves down with respect to the footwall, then we would call that a normal fault.